Okay. Okay, I am Jim DeFreeze, and this is ELC131 recording for today. Where I like to start is typically in Blackboard content. If you go to Blackboard, if you go to your courses, and they had to put you in, you go to start here, you do your EVA, and then what we typically would do would be the syllabus. And so the syllabus is pretty much standard. It's got the meeting times and days, which is Tuesday only. It's got my contact information. It's best to email me. I'm usually on the third floor when I'm here, usually in either the classroom of class or this end. I'm supposed to update this. I was going to do it during class. I'm not going to do it right now. If you reach out, usually I try and check email daily, so I should exceed the 48 hours. I try and grade at least twice a week, catch up my grading. So I should exceed that. And as far as your progress, I'll show you. I don't know if I can show you, but I can tell you where you can go to see your progress anytime you want for the class. There are no materials for the class. That being said, if you go to Google and you do lessons in electric circuits, or you search this guy's name right here, I don't know if you can see that, Kuphaldt, Kuphaldt. This is usually your first hit. And he wrote an online version of DC-AC and semiconductors and digital and everything. So primarily we're going to be in volume 1 and 2 this semester, but we will also do some stuff in the reference part. So if you need to go to a source that you can look at and say, oh, I need to do that, this is where you go. So you can bookmark that. I think you can still download it. His index for DC is concepts of electricity, Ohm's law, electrical safety. He assumes you know some Ohm's law to do electrical safety, so he talks about it from the standpoint of Ohm's law and basic concepts. So at some point you should read the chapter on electrical safety, kind of get the idea of why things are the way they are, because you are the one that's most responsible for your safety. Others are doing things to keep you safe, but your actions are the things are what's going to keep you the safest. So you need that awareness. I normally start with scientific notation and metric prefixes. And then we get into the different types of circuits, which I tend to lump under DC network analysis. So I don't follow his outline exactly. I sort of do my own thing, but you can certainly find information on what my worksheets are on from looking at his material. The first worksheet is going to have some metric scientific notation, and I call them engineering prefixes. He calls them metric prefixes. So he's got a pretty good description of that, and he writes well. So it's pretty easy to read and understand what he's saying. Eventually, we're going to get into capacitors, inductors, and that sort of crosses us over into AC, which would be the AC part. Another thing we do right off the bat is in the references. On the first couple worksheets, I will talk about color codes. I've got some questions about conductors and insulators. And so in the reference book, you've got some of the other stuff. He actually has a spice tutorial. And when he wrote this book, he was using a spice that was very old and it has changed some. So some of what's there is good, but it's not like you can follow it. He was using a text-based spice, pure text-based spice, and I'm trying to use one that's close to that, but it's not a perfect it's not a perfectly good reference circuit. So yeah, you can download it if you want it. I think the last time somebody downloaded it was over 3,000 pages. So it's quite comprehensive, but it's a reference book. You don't have to buy it. And so that's good. Content. Every class here is on 10-point scale. So if you get over a 90, over 80, etc. Then you get your course combining grade, final exam. I do have a final exam for this class. It's worth 10% or 100 points, as you'll see in a minute. And withdrawals, student course concerns. This is pretty much the same in every class. If you got a disability, you've got to document with this Office of Accessibility your disability, and then they tell me what accommodations I have to make. The thing that will be different between me and every other instructor is a section down toward the bottom that I call instructor specific. It lists when my office hours are, which basically is from 10 o'clock till the class starts on Tuesday and Thursday. You can best get up with me on email. These are the room numbers I'm in. And as far as your grade, I set my classes up so there is 1,000 points available. All right, mouse, behave. So there's 1,000 points available. I've got Blackboard set up to, if you don't have a submission for that work, you have a 0 by default. So your grade consequently is at a 0 right now, but it will only go up. So as you turn in work, you get it graded, then you will see that number increase. But it takes a long time to get to 600 points. So just don't let that get you down. You just want to be systematic about getting things in. At any time, if you want to see how you're doing in the class, you can look at that total column in your grade. You can move the decimal one place to the left, and that is your grade out of 100 points. So initially you have a 0. And then as you turn in work, eventually at some point in the semester, you cross the 600-point threshold, you're guaranteed a D. You cross the 700-point threshold, you're guaranteed a C. And you can go as far as you want, and that you've got assignments for. If on April 1st you feel like you cannot possibly finish all the material for the class, that is your last opportunity to drop the class, in which case you won't get the grade you have earned. You will get a withdrawal grade. For financial aid, it's the same as an F, but it doesn't hurt your GPA to withdraw. If you go past April 2nd, then I've got to give you a grade, and my policy is I'll give you a grade based on how many things you've turned in over the course of the semester. If you do 800 points worth, you get a B. 900 points, you get an A, etc. If it's less than 600, you're not going to be happy, but I try and be consistent. And I tell you up front, that's how it goes. This class meets Tuesday only, and I do not accept class work after the end of the last class meeting. So at 4 o'clock on the Tuesday before the last day of the semester, which is a Friday, I will not accept any assignments after that, either electronically or in person. There is a final exam for this class. If you are taking the final by 4 o'clock on that last Tuesday, you will have the opportunity to finish, and I'll count that. But that is the syllabus, basically. If you got any questions, you can ask me. So you review the syllabus. I didn't back out right. Then in course content, if you didn't do the EVA, you won't be able to see the assignments. If you see the assignments, you'll see that there are 28 assignments over the course of the semester. So it's basically 2 a week. When we get down to 25 and 26, this will be very late in the semester. You will be given a couple individual circuits to build, analyze, demonstrate, and troubleshoot. Your circuit's going to be unique from any other student in the class, and it's going to be one-on-one, you showing me how it is. My goal is to give you enough practice up front that this will be easy by the time we get there. It might not seem easy right now, but 24 is basically a warm-up. And then there's some other circuits ahead of time where I get you some confidence troubleshooting and everything else. So by the time you get here, you should be okay. 27 and 28 basically are reviews for the course to get you ready for the final exam. So those should be the ones you do last, right before you take the final. There is no new material on 27 and 28. So all the material for the class comes between 1 and 24. And then we wrap it up at the end. Now through worksheet 24, didn't mean to do that. Through worksheet 24, if you do terrible on an assignment and you see what you did wrong and you fix every part of it, you can raise that assignment grade to 90%. So you can get 100% if you get everything right the first time. And if you get really bad and you want to make corrections, then you can pull it up to a 90 as long as you correct everything. Okay, if you only correct part of it, you might not get to a 90. So what I'm trying to do is get interactive and get you feeling good about, you can look at the worksheet, you can see what you need to do, and then you can learn it. I'm going to throw a bunch of stuff at the class first part of the semester, but it's something you're going to see over and over and over. So as you see it over and over, your confidence, your comfort with actually doing these problems is only going to go up. So today, normally I would do the first 2 worksheets, and I can make those bigger. So there's scientific notation. So if you don't know what proper scientific notation is, it is 1 digit, not 0, to the left of the decimal. However, there is another scientific notation that's not proper. You can put as many digits to the left of the decimal as you want to, but it's not proper. Proper is only 1. Engineering notation is what Kupholt calls the metric prefixes. So sometimes you can take a tens power and you can reduce it to a prefix. And then we're all on the same page. So I've got a couple of examples of those. And then the resistance values of a 4-band resistor. Again, Kupholt's got the reference of what all that means. It's something I would go over first day of class, but I'm having to say, hey, you got to look in the book. When everybody's here, we will go over it if we need to. That's fine. I also want to introduce you the first day of class to Scilab. Scilab is also a free software. So if you search for Scilab, it's going to go there. Well, it did. Now, no. All right. Oh, it was loading. And I stopped it. There you go. Scilab comes from Data Systems. It will work on Linux, Windows, and Mac. I've had some students tell me that in Mac, there's some weird stuff that it does, but you can sort of figure it out. It's an open source software for numerical computation. You may not want to yet or have not thought about it yet, but if you go off to UNC Charlotte and get a 4-year degree, they're going to expect you to do MATLAB. Scilab and MATLAB are similar. They are not the same. Scilab is free. MATLAB you have to pay for. A lot of the syntax is there's some differences in syntax, but as far as the way it works and the way it looks, Scilab and MATLAB are definitely cousins. Let's just go with that. So I like to have students do Scilab on the computers I have in the classroom, and I've got 12. I think we got less than 12 students that you're welcome to use. Scilab's on it. And let's look at the first worksheet again. Scientific notation. What you're typically used to seeing is something like this: 2 times 10 to the 5th plus 3 times 10 to the 3rd. That would be scientific notation. So what I want you to do sort of is use Scilab to do these. If you're really good at the exponents with scientific notation and everything else, and you want to do it by hand, I strongly encourage that because it's a good skill. If you're not, then you got options. So that first problem, 2 times 10 to the 5th plus 3 times 10 to the 3rd in Scilab, you would enter as 2e to the 5. The e means times 10 2. Excel uses that shortcut. Scilab uses that shortcut. So it just makes it easier. So if I type it in and I hit answer, I get an answer. So basically I'm adding 200,000 to 3,000 and I get 203,000. And if you put Scilab in scientific notation, it would then tell you the answer is 2.03 times 10 to the 5th, which is the same. So I've got a number of examples that you can solve in Scilab. You're adding, multiplying, subtracting, dividing, multiplying 2 together, dividing again, because that's really the most important. And down here, these bottom 2, you're actually raising a power to a power. That's one you would do the way you think it would with the up caret. The other thing we use Scilab for is simultaneous equations. So you've probably been in a math class where somebody's giving you simultaneous equations, they say solve them. And you can teach a whole math course on how to solve simultaneous equations. And what I try and do is give you an easy way to solve it that always works and will work for the AC side of things, when we get to it. So I give you an example here: 3x plus 2y equals 5, x minus y equals 5. And what you want to come out of your simultaneous equations with is they got to be in standard form. And then you want to come up with what's called a coefficient matrix. So 3 is the coefficient of x, 2 is the coefficient of y, 5 is the constant. And on this one, 1 is the coefficient of x, but nobody writes the 1. So you got to understand it's a 1. This one is a negative. So anytime you have a negative, that pulls itself to the coefficient. So the coefficient of the y here is a -1. And then 5. So if I go to Scilab and I do 325 semicolon 1 minus 1 5, it doesn't know what I'm doing. Because I put it in parentheses. But look what happens when I put it in brackets. If I put it in brackets, 325 1 minus 1 5 in brackets, this is my answer. And I like doing it as a two-step problem so I can make sure my coefficient matrix is right. I've gotten a lot of students lately, they want to do it in one step. You're looking for the answers. If you get the right answers, it's great. So anytime you do a calculation in Scilab, it comes back with answer, answer, answer. And over here, you've got your variable. So your variable answer will always show up. And anytime you do a new calculation, whatever value is calculated will overwrite whatever was there. If you want something to stay in memory in Scilab so that you can use it over and over again, then you've got to assign it as a variable, like I did problem 2. And so I just typed problem 2 equals, and then the same matrix I did up here. And you see that when I hit the enter, I got problem 2, and I got the same matrix. Okay? So if you got simultaneous equations and you can get that coefficient matrix, then all you got to remember is RREF. This is a linear algebra term. What you're doing is you're reducing this matrix to its lowest possible form. And that gives you the solutions. Because if this farthest left column here is the x values, and these are the y values, and these are the constants. If I come down here and say, these are my x values, these are my y values, these are my constants, what you see is I got one x or x, no y's, so we don't write y, equals 3. So this basically is interpreted as x equals 3 and y equals -2. That's your solution to those simultaneous equations. And then please go back in there and plug them in, see if they work. Because if you made a mistake in the calculation, then your solutions won't work for both. So 3 times 3 is 9, plus 2 times -2 is -4. 9 minus 4 is 5. 3 minus the -2 is 3 plus 2, which is 5. So in this case, they work. So you can always know that you got your simultaneous equations right. And that's the easiest way I have ever found to solve them. And I give you another example. One to try on your own, but it's the same process. My worksheets are 15 problems long. And so if you do download a worksheet and you don't see 15 problems, then sometimes Word won't show you the second page. I am using LibreOffice. LibreOffice is free software. It's a word processor. So you can have it on all the computers you want. You don't need a license. Word will open them, but sometimes it does funny things. So if you don't see a problem 15 on your worksheet, let me know. I can convert these to PDFs, send you the PDFs. You can open the PDFs. Most students want to go ahead and type their answers in, download and type in their answers, and then send it to me. If you do type in your answers, please change color. Make it easy on the instructor. Anything you add, please change the color. I don't care what color you change it to as long as I can read it. Some students don't, some students do. It's a mixed bag. So that's worksheet 1 basically. And then I got worksheet 2. Had we met today, I want you to take 2 random resistors based on color code, find the range value. Most of our resistors are 5%. So whatever the value is, the nominal value based on the color codes, you're plus 5%, you're minus 5%. I'm wanting you to actually give me a number there. So if I've got a 100 ohm resistor, then my minimal acceptable is 95. My maximum acceptable would be 105. And then I would give you a resistor that you could measure in the lab, and you could write in that value. And then based on these minimum and maximum, if it's within the range, you can tell me yes or no, it's in tolerance. So it's just an exercise in getting familiar with color codes, making measurements, being aware of tolerances. So then I'm going to give you 820 and a 6.8 K ohm. You're going to measure them, and then you're just going to tell me, is this intolerance? Is this intolerance? Also, had we met today, I don't have a period there. You set up a DC source to the breadboard. We build a lot of circuits on a breadboard. So the first aspect is get the voltage source right. So we're going to go slow, set up positive and different positive voltages. It's a DC source, so it's like a battery. You can swap the polarity. So if you need a negative voltage, you can get it. Then I change gears. I go on to insulators. Some knowledge of an insulator and what conditions will current flow through an insulator. Air is a pretty good insulator. When does current flow through the air? And the answer is when there's enough voltage to push current through the air. So anytime you see lightning strike, you are seeing current flowing through an insulator. And I don't know if this wording is right because it confused me earlier. If you've got a circuit, oh, I should have made that bigger. If you got a circuit, you should measure the value of the resistors before you build it for a couple reasons. A, to make sure you got the right resistors. Sometimes if a resistor gets hot enough, red will turn to brown. The color red will turn to brown, and that throws off your value that you come up with. So if you measure it, you sort of know that, wait a minute, something's not right here, and you can go look for another one. So that is another thing that I want you to be aware of. Then I go to Spice. The other software that I typically use is something called NG Spice. Did I look it up here? LT Spice. So if I go to LT Spice, it's analog devices. You can download it. Again, it's free. I am trying to use something called NG Spice. It is more text-based. There's nothing graphical about it. And so I'm trying to make myself go there. LT Spice is still free. I don't know if it's at some point not going to be supported or whatever. It is comprehensive enough. It can get you all the way through graduate school, get you to being a doctorate in electrical engineering or whatever. We're just going to stay very basic with it. So LT Spice I will sometimes use because it's quick and I'm good at it. Okay. So if you open up LT Spice, I never update mine because we are going to stay very basic. And this little thing is the component. So if you want a voltage source or anything like that, you got to go to component. It actually looks like a digital gate. And you can put a voltage anywhere in your circuit and however many you want. They have a symbol for resistor. And they have a symbol for ground. In NG Spice and LT Spice and Multisim, you got to have a ground point in your circuit. The underlying software that does all the solving has to know where ground is. So in LT Spice, you give it a ground symbol. In NG Spice, you have a node 0 or a wire 0, and then it knows the node. And see, now it's like a video game. So if I give you a voltage and a resistance and I say how much current's flowing, you can say, wait a minute, let me build it. I'm hovering over the part. I'm right mouse clicking. And then at least for DC, all we have to do is put in the voltage value. So now I've got 12 volts DC. Hover over the part, right mouse click, you can put in the resistance value. Okay. Now where that question on the worksheet comes from is analysis. So if you simulate, you can run, but you got to, before you can run an analysis in Spice, whether it's Multisim or LT Spice, and NG Spice, I got to do it. I got to do it and remember. You're going to edit the simulation card. Well, for DC circuits, it's the easiest thing in the world. It always comes up in transient, but what you want to do is do DC operating point. And what that's going to do is that's going to put that little dot op on your circuit. And now what you're telling Spice to do, when you tell it to run the analysis, it will analyze for DC, which goes back to the question. What Spice command that returns the DC operating values for a circuit? Yeah, it's that easy, .op. Whoops, where am I? There we go. Now I can run the simulation and it tells me I've got 12 volts, which I knew, but it's giving me the current through that resistor, which is 0.2 of an amp. If I close that and I hover over the resistor and you look down at the bottom, see this bottom gray bar? When you hover over the resistor, it will tell you the current flowing through it, and it will tell you the dissipation, how much power it's having to dissipate. So any circuit in the world you can build, any DC circuit in the world you can build and analyze with something like this. In NG Spice, you got to look at the net list. And so what you see here is whenever you create an LT Spice circuit, it builds a net list for you. In NG Spice, you would put in the voltage, the resistor, what nodes they're between, and the values. And then you would do a .op. The back anode is something LT Spice has added to do that analysis that shows you the power. So it's very user friendly and it's free. As long as it stays that way, I don't really care. Multisim has way more options. It's way easier to use. You can actually put meters in the circuit, and the meters will then tell you what the current is, and you can have the voltmeters across things, and the voltmeters will tell you what the voltage is. But As a student, you can get a student version of Multisim, and I don't know what it is. It's probably free for 90 days. But if you are no longer a student and you want Multisim, it's between $3,000 and $5,000 a year. I don't know. I haven't met a student that's willing to put that much out for software to solve circuits. So anyway, 3 forms of Ohm's law. That's the critical law that we do all semester. There's 3 forms. And then to finish out the last worksheet, find the power. So the basic electrical components in Cup-Halt, he'll talk about power at some point. Everything we build on the bench usually uses 1/4 watt resistors, which is 0.25 watts. And one of the things we do from a safety standpoint is we like to know if our circuits are safe to build. So this is an exercise that says if I've got a 5.6K resistor and I've got 10 volts, how much current will that resistor dissipate? How much power will that dissipate? And then is it safe to build in a 10-volt circuit? So I can go back to my LT Spice and I can change my DC value to 10. And I think it's 5.6K. 5.6K. And then I can just rerun it. So there's my 10 volts. There's my current. Most of our currents that we'll build in the lab are going to be that small. It's going to be 0.0017. So that's 1.78 milliamps. If I close it and hover, I can see what it is. That resistor is going to have to dissipate 17 milliwatts. And it's got 1.78 milliamps of current. So I could go back and fill that in on the table. Since 17 milliwatts is less than 250 milliwatts, which is what a 1/4 watt resistor would be, it's safe to build. So basically, this is just an exercise in doing some circuit analysis and power. Pretty simple circuit. Get you used to it. Get you comfortable with it. And there's enough repetition there that you should be able to get pretty good at getting around in Spice. NG Spice, LT Spice, whatever you want. And that would get us through worksheet 2. Now, obviously, we'd go slower. We'd have some bench time if we were actually in a class. This kind of gets you through what you need to know for today. Next week, we don't have class on Tuesday. It's a break day for students, so we don't meet again for 2 weeks, in which case I would like to, we'll do what we need to in 1 and 2. We'll go over whatever I can write on the board, share all that, and then hopefully go on to 3. And try and do 3 and 4. We got 4 hours. So we'll see what we can do. We'll be down, we'll be in the right room for that. Electrical charges, like charges, 10-2 blank. Unlike charges, 10-2 blank. So I don't remember where it is, but that's a pretty easy concept, and it's one that's repeated in electronics. So, did I cover everything I intended to? I think so. Oops. All right, I'm screen sharing.